Okay, here we have the Ionic dice worksheet. So we have our lovely solo cup full of dice and a big, huge table. Looks daunting, but trust me, it's not that hard. So we're going to roll the dice, okay? And every time you roll the dice, you're going to notice that you're going to get 3 ions that have positive charges, or 3 cations, okay? And you're going to get 3 ions with negative charges, so we have anions. Okay, this is going to allow you to fill your table 3 rows at a time. And there might not be an exact multiple of 3 on this worksheet, but just roll the dice until you fill the table. Okay, you might have a couple extra dice floating out there, but that's okay. So the first thing that you do is you take your 3 cations and you fill those into the first 3 rows in the cation column. So we have magnesium, Mg, and it's a +2 or 2+, either way, technically more correct if we write the number before the charge. We have NH4 with a 1+ charge, so NH4 with a positive charge. And we have Cu with a 1+ charge, so Cu+. Okay, 1s are optional. Just make sure you don't accidentally think this is a 4+ charge. It's 4 hydrogens with 1 nitrogen. This is a polyatomic ion. Those were in chapter 9.1, and we made some flashcards of those. Next, I have my 3 anions, and you should randomly put them together, okay? Don't try and make your life easy, because it won't always be easy on a quiz or a test, so don't always try and match your charges up. But here, if you just make it random, you should be fine. So NO2 with a 1- charge, CO3 with a -2 charge, so 2- is more correct, but I didn't write them correctly when I put the dice on there, and Br with a -1 charge, so Br-. So you can do that to fill up your entire sheet with ions. But after you have your ions, you start making your compounds. Okay, so first off, you can do the name or the formula. Remember, with ionic compounds, the name is the cation followed by the anion. If your cation is in group 1, group 2, aluminum, zinc, silver, or cadmium, then you do not need a Roman numeral. But all of the transition metals other than zinc, silver, and cadmium need a Roman numeral to show the charge. Okay, so this one is in group 2, so it's just magnesium. Okay, and then if we have polyatomic ions, you just write their name exactly as it is on your flashcard or in the table in 9.1. So NO2 with a -1 charge is nitrite. So that's what I'll write, Nitrite. Okay, magnesium nitrite. This next one, NH4, is a polyatomic ion, so again, that's just going to be something that we'll memorize their names. NH4 is called ammonium. And it's going to be bonded with CO3 2-, another polyatomic ion, and that is called carbonate. Remember, our ITE and ATE signify that there's oxygens in that polyatomic ion. And then finally we have copper and we have bromine. Well, copper is a transition metal, so that means we have to show its charge in the name, and that will show up as a Roman numeral. Since it is a +1, we just use Roman numeral 1 in parentheses, so copper 1. And whenever we have a simple anion, monatomic anion, we are going to be doing the name of the element and changing it to IDE at the end, ide. So instead of bromine, we have bromide. Okay, so when these make a compound, magnesium nitrite. When these make a compound, ammonium carbonate. When these two make a compound, we make copper 1 bromide. Now for the formulas, remember, all ionic compounds are electrically neutral, so the charges have to balance with each other. So we have magnesium, which is with a 2+ charge, and we have nitrite, has a 1- charge. Those do not balance. Okay, we need to make this electrically neutral. We would need 2 nitrites to balance that +2 charge on the magnesium. So because nitrite is a polyatomic ion, I can't just write MgNO2 because that looks like we have 22 oxygens. But we don't want that. We want 2 nitrites. So we have to put parentheses around NO2 with the second 2 on the outside. 2 nitrites to balance 1 magnesium. With ammonium carbonate, similar process. Okay, a positive 1 charge does not balance a negative 2 charge. So we're going to need 2 ammoniums, 2 of this entire polyatomic ion, to balance this polyatomic ion. Because I need 2 of them, I will have to put it in parentheses. If I don't, again, if we wrote NH42CO3, this looks like 42 hydrogens. So we squeeze those parentheses around NH4. We have 2 NH4s balancing out a CO3. I do not put parentheses around CO3 because there's only 1 of them in the compound. Remember, one way to figure out your ratio is if you look at the number of this charge and you bring it down here, that's a 2. Okay, 2 coming down here. The 1 from the ammonium would come down here, which we don't write 1s, so we end up with this. Here, positive 1, negative 1, they do balance each other, so we just squeeze those 2 symbols together, CuBr. That's copper 1 bromide. You will never have a charge written in your ionic formula, ever. You have charges written when you have single ions, but when you combine them to make a compound, remember it's electrically neutral, so we don't show charges. Charges only appear in the name if we're talking about a transition metal. Because they can have more than 1 charge, you have to show it as a Roman numeral. Remember, the 3 exceptions to that are zinc, silver, and cadmium.